truly an honour to welcome you all today to our first Ultrapolymers Innovating Healthcare Together event. I'd like to thank you all for making the time to come and join us for what I hope will be an interesting and exciting event. I'd also like to send a particular thanks to our speakers who've joined us today, who've put in the additional effort to give you some hopefully very compelling presentations. Looking around the room today, I see a great group of people with a lot of different experience, insight, and also leadership within the healthcare industry. As I say, this is the first time we've had an opportunity to bring people together like this, and I'm truly excited about the potential collaboration we're going to get from it. We've crafted what I think is a very compelling agenda, which I'm pleased to share with you now. We're going to be starting, well, it was initially going to be with my colleague Robert and I, but unfortunately he can't make it today. So we're going to kick off with Alexander at the back, who is from Plastics Europe, who is going to take us through the circular economy of plastics in healthcare. Following that, we're pleased to introduce Bernd from Ineos Styrolution, who is going to talk to us about how styrenics are innovating healthcare. We're then going to have a short break, which will be followed by Alessandro and Mathieu from LyondellBasell to take us through their sustainability approach for healthcare and how it's unlocking possibilities in the industry. We then hand over to Julian, who's from Biovox, who will be talking about innovating in sustainability and how collaboration really conquers complexity. And then you'll hear from me again, as I'm going to talk to you about what a polymer distributor's role in healthcare is in 2025. Tomorrow, we've got a great group from Ypsomed, Ramedic, and also industry leaders such as Engel, Team Consulting, and Moldex 3D to take you through the end of the show. We're going to have a break at about 2:20 today. You'll see QR codes pop up around the presentations, as well as in your booklet, for you to give your opinion on the industry and also submit some questions for the panel at the end of the day. Just after I speak at 4 o'clock, we'll start with the day one panel discussion, where we'll welcome the speakers back for an interactive session where we'll go through your questions that you've submitted either in person or via the QR codes. Now, we've got quite an exciting and interesting plan for the end of the day, which does unfortunately leave us a little short on time. So we're going to look to wrap up at about 4:30 and then meet in reception at about 10 to 5. Where we'll be walking to the cable car to take a nice journey. And apparently, there's a surprise at the top, which I don't know about, so you'll learn with me. Hopefully, it's a way back down. After the hike, we'll come back down here about 7 o'clock for dinner at 7:30. Now, it's important to say that we're going to have a lot of discussions, and there is an overlap within our businesses and our industries. So please be careful not to share any sensitive information from a commercial or developmental standpoint. And if at any point you're concerned or you're uncomfortable, please pick out someone from Ultrapolymers who can help. So what I'm pleased to do is also say that from a safety side, there are no fire alarms expected. So hopefully we don't get interrupted. And if they are, hopefully tomorrow when we're less pressed for time. And I would like to, introduce Marcus, who's going to be very kindly comparing for us today. And Marcus, up you come. All I'd say is also please, if you could keep your phones on silent just through the sessions, it would be greatly appreciated. So, Marcus, over to you.
Thanks, Richard, for the introduction. Hi, my name is Marcus. Marcus Bayer, and I'm honored today to introduce all of our presenters. And from my side, many thanks for all the presenters who can come today and give us a bright overview. So the next and the first presenter I would love to introduce is from a company who's working very, very close to support the goals of the UN Plastic Convention and had a very important voice in the market. So I'm delighted to invite you to Dr. Alexander Kronimus with the topic Circular Economy of Plastic in the Medical Sector with PlasticsEurope.
Thank you very much, Marcus, for the kind introduction. Good afternoon, ladies and gentlemen. I'll be happy to kick you off with the first presentation. You need to start. Oh, sorry. Good afternoon, ladies and gentlemen. Very Thank you very much, Marcus, for the introduction. And I'm very happy to be here at the pole position and to kick off with the first presentation on the circular economy of plastics in the medical sector. And I will subdivide my talk into two fractions. The first one, two parts. The first one will be on a general target picture of a circular economy from the viewpoint of the plastics manufacturer, which are represented by Plastics Europe. And the second will dive deeper into concrete projects of circularity in the medical sector. Let's start first with the challenges we are faced with when we look at the plastics utilization worldwide. On the left, you can see the outcome of a study of the OECD from the year 22, revealing an outlook on the plastics utilization worldwide. And we can assume 2019 as almost nearly as today. And today we are using round about 400 million tons of plastics worldwide on an annual base. And it is expected that that amount will double or even triple depending on the scenario until the year 2060. So we'll probably exceed the 1 billion ton of annual use plastics in the year 2060. That's on the one hand a healthy outlook for the plastics industry. On the other, it bears some risks because the waste amounts will also increase dramatically and exponentially, and those waste amounts is bearing some risks. Because if they are not properly managed, they will end up in the environment and will even enhance the stocks of accumulated plastics. And we need altogether an answer on those risks, and our answer is a circular economy with plastics. A short look on the figures, a short glance on the figures of Europe. In Europe, we are using around about 60 million tons of plastics entering the market on an annual base, and 20% of these plastics are based on non-fossil feedstock, on circular feedstock. These are around about 13% of mechanical recycled, post-consumer recyclate, 5 to 6% based on mechanical recycled post-industrial recyclate, around about 1% bio-based, and the negligible amount of 0.2% is based on feedstock from chemical recycling so far. The waste side looks a little bit different. So on a balance based, round about the half of the plastics entering the market are coming back as waste, around about 30 million tons, which are collected through the EU. And round about one half of that plastic waste, of that collected plastic waste, is incinerated. 1/4 is even today landfilled, and 1/4 is recycled. And of course, it has to be the job of a circular economy to transfer those landfill and incineration fractions back into the circle and back into recycling. And while it might be trivial to say, well, I would like to explain a circular economy to you, but I think it's worthwhile to take a couple of minutes on the understanding of a circular economy, because it's very important to have a common understanding on this. I will start here at 8 o'clock with the feedstock. The feedstock, as we have seen, is today, the majority is fossil-based, 80 to 90%. Worldwide, it's 90%. And that feedstock is used then for pellet manufacturing. That's the core business then of the companies represented by Plastics Europe. Then there's the processing step where the pellets are turned into products, and then those are entering the markets. And already at a stage between processing and market entrance, we can apply circular principles such as the reduction of unnecessary material and the reuse of products, and other principles of the R strategies, the so-called R strategies, for example, making products repairable. But any products, we have to expect that any product entering the market will once become waste. So it's important that there is a waste management in place, meaning that the waste is collected that the waste is collected and separated and being subject to recycling to the utmost extent. And for recycling, our target picture foresees two principal technical pathways. First, here in blue, the mechanical recycling, meaning repelletizing plastics waste, thermally repelletizing plastic waste. And another one is the chemical recycling pathways. Mechanical recycling is usually the most efficient way of recycling you can imagine, because it requires not too much resources and not too much energy. However, there are certain waste streams like thermosets and contaminated or mixed waste streams which cannot be covered by mechanical recycling today. So we think that here the chemical recycling is should accompany the mechanical way and should maximize the overall recycling. However, it's very important that those streams are not competing with each other. Instead, they should be in an ideal world complementing each other. So the chemical recycling leads not to new pellets, that leads to a new feedstock, recycled hydrocarbon feedstock, which can then be used to produce new plastics. And I would summarize those pathways as technology neutral recycling. However, we have to be able to recycle at all, and therefore we have to apply the principles of circular design, meaning that we have to think about the end of life of a product already during its design phase. But that's still not sufficient for a circular economy. We have seen that the 30 million tons in Europe coming back as waste are not sufficient to cover the demand of new plastics. And therefore, if we want to become climate neutral, we have to complement here the recyclates by other alternative feedstock, not being based on fossil fuels, and therefore the drilling rack has to be removed and substituted by alternative feedstocks. Now, how would those alternative feedstock look like? Here, in green, we see the symbol of the hydrocarbon feedstock base. And that feedstock base relates in Germany, for example, to 20 million tons of hydrocarbon used on an annual base. And that's the fundament for the production of plastics and for many, many other chemical products. And now using the German figures, that feedstock base is underpinned by 86% of fossil fuels today and by around about 13% renewable resources. And that picture has to completely change if we want to become climate neutral. And for Germany, that's in the year 2045, because we are obliged to become climate neutral by law by 2045. In Europe, it's a little bit later. It's 2050, according to the Green Deal. And in that scenario, we have to substitute the 86% of fossil-based fuels by something else, which is not based on fossil fuels. And there are three opportunities. There's recycling. On the one hand, the mechanical recycling, turning plastic waste into plastics again. With chemical recycling, we can feed here into the hydrocarbon feedstock base. There's another opportunity by biomass, probably used in the future in a higher magnitude. We are using it today. And third opportunity is carbon capture and utilization, meaning capturing CO2 from point sources or direct from the atmosphere and accompany it with green hydrogen. That's a very elegant way on the one hand. On the other, we know perfectly that such a way requires a lot of renewable electricity to drive the water electrolysis for hydrogen production. So as a conclusion here, with any additional percentage of recycling, we can reduce the amount of the scarce resource renewable electricity, and that's why recycling is such important. Here is an example of circular design. That's from the K Fair in the year 22. It's a car seat. It's here covered by persons. However, you can also see the seat here on the left. The specialty about the seat is that it consists of one material only. In that example, it's polyamide 12. If you look at current car seats, they have a cover, they have a side cover, they have the foam, they have the metal frame. So we are using 3, 4, 5 different materials in nowadays car seats. However, that is a study of a seat that uses only one material. So it's a monomaterial seat, and that has a big potential for a high recyclability. And I think that's a really good example to show how circular design could work. So for now, I would close the general part on the circularity, on the target picture of a circular economy with plastics, and make a deep dive into concrete projects of circularity in the health sector. First, I have to mention that, of course, plastics are very important in the health sector. They are used in many medical devices, syringes, and others, due to their key properties, lightweight, the potential for sterile application, the cost efficiency, and of course, the favorable mechanical properties. In healthcare, we use a wide variety of polymers. However, some polymers are more often used than others. For example, PE, PVC, polystyrene, and polypropylene. There are also technical polymers used like PET or nitrile-based polymers and many others. And I want to have a brief look on the input of the plastic polymers into the medical sector. That slide is in German. My apologies for that. However, it is not that difficult. We can see here medicine means the medical sector, that around about 0.3 kilotons of plastics is transferred into the medical sector, and that makes up to 2% of the whole processed plastics in Germany. So these are German figures. So the inflow of plastics in the medical sector is not too high. However, if we look at a certain hospital, the relative amount of plastics used there is really, really high, and there's a relatively high amount of plastic waste compared with the total waste produced in hospitals. So it's very worthwhile to have a look on a circular economy with plastics in the health sector. And the COVID crisis even increased the use of single-use plastics items. Of course, in the medical sector, we are faced with certain challenges due to the hygiene requirements there, and that has specific challenges in proper disposal of medical devices, the collection and the recycling. In the following, I would like to shed a light on some projects, some circularity projects, mainly related to PVC. PVC has a relatively high fraction or has a relatively high importance in the health sector. Around about 27% of PVC of medical devices in Europe consist of PVC. Here's also a distribution about over several different applications, and we can see that for example, looking at catheters, the PVC percentage is quite high. And rather a little bit more than 120,000 tons of PVC is used in the European medical sector. And one project running here in the PVC medical sector is the so-called Vinyl Plus Met project. Vinyl Plus is the associations of the PVC value chain, so manufacturers, processors, and recyclers. And they launched in 2021 the project Vinyl Plus Met, to accelerate the circularity in healthcare across Europe. And the instrument of choice is recycling. So the project is focusing on the recycling of medical devices and to turn them into REACH-compliant, high-quality recyclates. The project started in Belgium, and however, currently it's already spilling over to other European countries, for example, to France. And here, down here, there's the process chain of this project. So single-use medical devices are separately collected, for example, here PVC tubing, and the collected waste is turned into high-quality regrind, and that is used then to high-quality application. It is not used in the same application again, but in that example, it has been used in wall covering for healthcare, and that might seem a downcycling process, but it isn't actually. The wall covering in healthcare is quite demanding. It has to be hygienic. It has to be dimensional stable, resistant to chemicals, and impact resistant if we think about beds bumping into the wall coverage in hospitals and other mobile devices which are used in the hospital atmosphere. And in 23, already almost 30 hospitals have been participating in the project. More than 30 have been on the waiting list, and there have been more than 3 tons of PVC collected in 2023, and a whole huge number of oxygen masks has also been collected to be subject to recycling. And well, it is not a circular economy alone is not a value. It turns into the value if it has a positive impact on the environment, and the positive impact on the environment could be demonstrated here by a study made by EU Weimt in 24, and it could be shown that the CO2 footprint of a recycled PVC tubing compared to the incineration can be reduced by 25%. So that's quite an advantage. And if we think about more than 6,000 tons of PVC being used each year in Europe to produce medical tubing, then the PVC application alone in medical tubing could be reduced by 80 million tons of CO2 due to PVC recycling. In the project, there are also other products in the scope besides tubing, for example, also masks. Also masks here shown on the left, and certain medical bags for dialysis and EV applications. And recycling, once scaled, can lead to certain advantages, to cost savings due to the saving of resources, to energy and CO2 savings. I could show that there are really CO2 savings possible. We can obtain high-grade recyclates, probably not used in the same application again, but in other high-value applications. A safe collection does not pose higher risk in the medical sector than when using virgin materials. And finally, it's an untapped resource, because it has been calculated that within a 300-bed hospital, 2.5 tons of PVC per year could be alone collected in the area of oxygen masks and tubing. So there is a second project underway by Vinyl Plus. It's called Vinyl Plus Farm Pack, and it's focused on such blisters combining PVC and aluminum. And in several small-scale tests, it could be shown on the laboratory scale that the aluminum and the PVC fraction could be separated successful. And first demonstrations have shown that the PVC can be successfully recycled. Now, currently, that project is busy with scaling that project. So the guys are busy to establish larger scale trials. And that will be followed by the installation of a dedicated pilot plant. And the recycled PVC coming out of this pilot plant will be then subject to further investigation. There are additional projects, for example, the Select for Care project. I talked a lot about recycling, and recycling will be the way to go also for a long time in the medical sector, because we have those hygiene requirements. However, there's a certain potential also in the medical sector to reuse also devices, and the Select for Care project is investigating the reuse potential in the medical sector. Another project was picked up from the Grand Hospital of Charleroi in Belgium, who launched the PVC recycling at 3 different sites, and that recycling has a potential of recycling 50 tons of PVC devices per year. So that's quite already a scaled project. The current projects are mainly focused on mechanical recycling. However, I think and we think that chemical recycling is also quite valuable and has a high potential in the valuable sector if we can think of the hygiene requirements, because chemical recycling can lead to, well, virgin-like new products, although they are recycled. So chemical recycling can in principle lead to recycling where a syringe is recycled to a syringe again. So the potential of chemical recycling has to be explored in more detail in the future, and also alternative feedstock like bio-based should be explored in more detail for the medical sector. There are already companies who are engaged in using bio-based plastics for the healthcare sector. So I would like to close the presentation with an outlook. We have some challenges with the high quality required of plastics in the healthcare sector due to the hygiene requirements. There are nevertheless projects underway for collection, recycling, and the reuse of plastic in the healthcare sector. The current projects running reveal that a saving of emissions and resources due to recycling is possible, and it's also conceivable. However, we need more research for scaling and the development of additional technologies like bio-based feedstock and chemical recycling. And here I'm at the end of my presentation, and I thank you very deeply for your kind attention. Thank you very much.